Let's take a look here at solving absolute value equations and inequalities. So we're going to be combining the two things that we just finished up doing, but we're going to do a couple different things in here. So make sure that you don't just skip over this video here. So number one, the absolute value equation here we want to know, is 2 a solution? So does 2 actually work in here? And so really all this is just does x equal 2? So if I plug 2 in for x, I want to know, does that come back out to give me a 6? And the answer, if I go through and I simplify this, I want to know, does that equal 6? Absolute value of negative 6. Sure, that's a 6. We're looking for the distance away from 0. And 6 does equal 6, so the answer is yes. That is a solution. That is part of the domain. It is a number that I can plug in that will come back to give me 6. Now, of course, we know that there are actually two answers to this. One of them is 2, and you could solve that to figure out what the other one is. I'm not going to tell you. Number 2. So now we've got absolute value is equal to, of negative y is equal to 6. Now remember that when we do absolute value of equations, all we're doing is taking the stuff inside, setting it equal to the left side, and taking the stuff inside and setting it equal to the right side. We're looking for that distance away from that middle number. So now this is a lazy one here, so I divide by negative 1, and I get y is equal to 6. Same thing over here, divide by negative 1, and y is equal to negative 6. Okay, so those are the two numbers that would be in the domain of this, two numbers that would make this equation completely true. Number 3, now this absolute value is not by itself, so I have to get it by itself. So I add 3 to both sides before I do anything. 8 minus y, absolute value. 1 plus 3 on the right-hand side is 4. Now that the absolute value is by itself, I can split it. I can do stuff inside equal to the negative, and stuff inside equal to the positive. Subtract 8 from both sides. I get negative y is equal to negative 12. Just like on the last problem, there's a lazy 1 there, so I get y is equal to 12. Subtract 8 on both sides. Negative y is equal to negative 4. Lazy 1, divide by negative 1, and I get y is equal to positive 4. Okay, and so I end up with y equals 12, and I kind of ran out of room, sorry about that, and y is equal to 4. Okay, so those are the two numbers that are in my domain of this equation. Now let's take a look at the inequalities. So when you have an inequality, and make sure you're paying attention because these are scattered throughout on this one, that when we have these inequalities, we have to actually be paying attention when we are deciding ands and ors, and if the equation or the inequality comes out to be no solution or all solutions, all those things. So I've got absolute value is greater than negative 4. Well, if I think about that, I already know that I can't take an absolute value and make it equal to 4, negative 4 rather. Okay, I can't do an absolute value to come back to be a negative. So equal to negative 4 doesn't make any sense. Okay, less than negative 4 doesn't make any sense either, because that would be numbers that are still negative, and I can't get numbers that are negative than that. But there are some numbers, namely all of them, that if I put absolute value around them, they're going to be bigger than negative 4, because every number is going to come out and be positive. Okay, so this is all positive numbers greater than negative 4. That's what that's asking. Can any positive number come out to be bigger than negative 4? And the answer is yes. Every single positive number is bigger than negative 4. And so this actually is all solutions. Okay, and so when we're paying attention, we can't just blindly say that there's a negative at the end, so it's no solution. That doesn't always happen with inequalities, because every single number would be bigger than negative 4 if I put absolute value around it. Okay, so I got to make sure that we're paying attention with these inequalities. Now, number 5, here's just a general rule. We've got it equal to 20, so I'm going to take the inside part. Because I'm making the answer negative, I have to switch the inequalities, so 2 minus 9x greater than or equal to 20. Okay, so I switch it on the left-hand side, and I leave it the same on the right. Now I just solved, so subtract 2 from both sides, negative 9x less than or equal to negative 22, divide by negative 9. Because I divided by a negative, the inequality switches again, so 22 divided by 9, the negatives are going to cancel each other out, and I just get 22 divided by 9, and that's perfectly fine. Subtract 2 from both sides on the next one, so negative 9x greater than or equal to 18, divide by negative 9, and x divided by a negative, so the inequality switches, is less than or equal to -2. Okay? This was a greater, okay? So this is an OR graph. And there are lots of numbers that are bigger than -2, or 22/9 and less than -2, and so that's fine with an OR in there. Problem number 6 here, I've got the absolute value is not by itself, so I want to do that first. That's a subtract 1, and I'm thinking ahead here because on the right-hand side here, 7 minus 1 actually is 6. So now I've got the absolute value with the positive answer on the right-hand side, and so I'm good. I can split this. I get 3x minus 5, change the inequality and change the answer. 3x minus 5, leave the inequality and leave the answer. Hopefully that still fits on your screen. I can kind of see it on mine. So I get 3x minus 5 greater than -6. I'm just going to solve this nice friendly equation. Add both 5 to both sides. 3x less than -1 divided by 3. X is greater than -1/3. I think I said less than, but it's actually a greater than. On this one, I'm going to add 5 to both sides, and hopefully this still shows up on your screen here. So I get 3x is less than 6 plus 5 is 11. I know that shows up. So then we can divide by 3, and I get x is less than 11/3. So now I've got a less than, and equation, so this is an and I want to make sure that it comes out to be true. I want numbers that are bigger than -1/3 and less than 11/3, and that's perfectly fine. There's lots of numbers that are bigger than negatives and less than positives. Okay, so even if you don't know where those numbers lie on the number line, which I would hope that you would, but if you don't, hopefully you see that that can happen. There are numbers that are bigger than a negative and less than any positive. So that goes through and it solves the equations and inequalities. Make sure that you're looking to pay attention to what is actually happening as they're scattered throughout this worksheet. Okay, so they're not always equations and they're not always inequalities. They're scattered throughout. Okay, so take your time and finish this worksheet asking questions as you have them.